This series of videos will be about section 7.1, Systems of Equations in Three Variables from College Algebra in Context. We'll be solving systems of linear equations in three variables using the elimination method. We'll find solutions to dependent systems and determine when a system of equations is inconsistent. So these are the things we can do with the systems of equations. We can interchange any two equations. We can multiply both sides of the equation by the same non-zero number, and we can multiply any equation by a number, add the result to a second equation, and then use that equation in place of the second one. Here's a system of equations. We can try that on. Okay, first thing I'm going to do is take the top equation, and I noticed this has a negative x, a negative 3z, or negative z, negative 3z, and negative 3z. So I think if I take this top equation times negative 3, that will result in negative 3x plus, or minus, it's a negative 3, negative 3y, now plus 3z will equal 0. Let's add that to the second equation. X plus 2y minus 3z equals negative 2. When I add those, I'll get negative 2x minus 1y, the z's will be gone, equals negative 2. Well, since I've got that negative 3 down here, let's also take this multiplied, the top equation times negative 3. And add it to the bottom equation. 3x minus y minus 3z equals negative 2. Oh, x's go out also, so I have negative 4y equals whoops, this is negative 1, not negative 2. Equals negative 1, so y turns out to be 1/4, and I already have one solution. Let's take that value and fill it in this equation. So negative 2 times x minus my y at 1/4 equals negative 2, so negative 2x, adding 1/4 to both sides, my negative 2 would be negative 8/4 plus a 1/4 will be negative 7/4, and divide that by 2, it will be 7/8. So x equals 7/8. Let's take both of those values and fill it in the top equation. So 7/8 plus 1/4 minus z equals 0. Well, adding these two together, 1/4 is the same as 2/8, so I'll have 9/8 equals, add the z to both sides, equals z. And I now have all three solutions. And you can check those in all three equations, or in these two equations, and fill them in also, and it does check. Now here's a situation, a real life example. On July 7th, 2004, Shania Twain was scheduled to perform in the TD Waterhouse Center in Orlando, Florida. The center offered 18,039 seats for the concert in three seating classifications: floor, lower, and upper. Based on their locations, tickets were offered at three different prices: floor tickets at $80, lower tickets at $65, upper tickets at $45. If the concert planners expected a total of 12,000 tickets would be sold, including 5 times as many tickets on the lower level as on the floor, how many of each type of ticket would be sold to reach this $675,000 in ticket revenue? I thought it was interesting. We're only going to sell about 2/3 of the have 12,000 total tickets be sold. So let's let the floor tickets be X, the lower tickets be Y, and the upper tickets be Z. So X plus Y plus Z will equal the 12,000. Now, we know we want a total of 6,750 tickets, and so we can use that. The floor tickets X are worth $80 each, plus the lower tickets are $65 each, so 65Y, plus the upper tickets are $45 each, 45Z equals the $675,000 in ticket sales. We also know this fact. There's going to be 5 times as many tickets on the lower level as on the floor. This becomes important. Now think about it. Where is there more? On the floor or the lower level? 5 times as many on the lower level. So the lower level tickets are Y, and there's going to be 5 times as many of those as on the floor. So that will equal 5 times X. Now, solving these, what I would actually do first is substitute this in to both equations. So I will have X plus, in place of the Y, 5X plus Z equals 12,000, or 6X plus Z equals the 12,000. That's one of my equations. And then I can we're going to fill that in. The 5X I'm going to take that equation times -45 and that's to eliminate here, but I also need to get rid of the y's in this equation. So let's get rid of the y's in this equation by replacing the y with 5x. So when I do that, this becomes 80x plus 65 times 5x plus 45z equals the 675,000. This would be 320x plus the 80 will be 325x plus the 80, 405x plus the 45z equals 6,750. Now multiplying this by -45, I will end up with negative 270x minus 45z equals negative 540,000.